Hey everybody, welcome back. In this video, we're going to practice dynamic programming to find the longest common subsequence to solve problem 583, delete operations for two strings. So in this problem, given two strings, word1 and word2, we should return the minimum number of steps required to make these two words identical. And at each operation, we can delete exactly one character from either of these strings. For example, here, if we remove S from the first one and then T from the second word, we can convert these two words to be EA, and it takes two operations. Or here in the second one, if we remove these first three characters from the first word and also the last character, we can convert it to this ETCO. And as you can see, these delete operations doesn't necessarily have to be applied on both words at the same time, so we can only apply it on one word. So let's say we know the lengths of these two words as L1 and L2. These are the lengths of these two words. And if we find the longest common subsequence of a given two words, and as you can see, the length of these two words is not that large, so 500 characters at maximum, so it is not a very big problem. So let's say we find the common part. For example, here, the longest common part or subsequence from these two words is EA. And let's say the length of that is LC. So it requires L1 minus LC to convert the first word into that common subsequence. Likewise, for the second one, it requires L2 minus LC to convert the second word into that longest common subsequence. For example, here, the longest subsequence, word 2 is already equal to the longest common subsequence, so these two values would be identical, but this one is 4 characters larger, so if we add up these two values, it is the answer for this problem. So in order to find the longest common subsequence, we define a 2D table, and for each index, we are going to use the previously calculated indices to find the answer for a given index. And what are these? So these two tables we have for given index I and j. The first one indicates indices for word 1, the first word, and the second dimension is for the second word. And at each index indicates the length of the longest common subsequence if we extract W1 until index I, and the second word till index j. So the value here indicates, if we extract these two parts, indicates the answer of length of the longest common subsequence till that index. And how can we use the previously calculated operation? So for a given, for a new value, let's say we want to calculate index I and j, and we know that these cells are already calculated in the previous iterations. So this one is I and j minus 1. This one is I minus 1 and j minus 1. And this one is I minus 1 and j. So for a new string, so it's like we are considering a new character for at each index. So if these two new characters are identical or equal, so we can consider this value, I minus 1 and j minus 1. So it is like we are subtracting or removing the ending character from these two strings. And since we know these new characters are equal, so the answer could be this value plus 1, because we know that these two characters are equal. So this value plus 1. And then for the value at index I and j, we can simply find the maximum of these 3 cells. You can either ignore that even if they are equal or not, and then just find the maximum of these values as the answer for index I and j. So let's jump into the implementation and we can discuss it further. So as we discussed, we should define a 2D table. So let's find the length of these two words first. So L1 and L2 is equal to the length of word 1 and then the length of word 2. And then we define a table as initialize it by 0 because it indicates 0 as by default. 0 is the length of longest subsequent addition index initially. So 0 times L2 for in range L1. In order to make our life easier, so consider the first of indices, the first row and the first column. As we discussed, for each operation, we should first look at the previous operations by taking a look at the left and upper cells and top left. But none of these cells does have any, so we have to initialize them first and then start the operation from the first index here so that this operation is valid. So for that, I want to add a pad of zeros to the left and to the top of this array so that when we are here at the very first at 0 of our table, it is valid and it has a top left cell at this 2D table. So I increase the table just for the padding purposes. So instead of having a 2D table of size L1 by L2, now we have a 2D table of zeros, L1 plus 1 by L2 plus 1. And I simply just do the operation for I in range word 1, L1. Or I can enumerate that in order to have that character. So for I and character 1 in enumerate word 1. For J and C2 in enumerate word 2. So this is the index for the first character and then the character itself, and likewise for the second word. What we have to do, we need to find a calculated table I plus 1 and then J plus 1. So this plus 1 is because of the padding that we added. So we are starting from 1 and 1 instead of 0 and 0. And we want to find this using table ij, table I plus 1 and j, and table j and I plus 1. So for that, let's say, first of all, if, let's say, if C1 equal to C2, then the table I plus 1 and j plus 1 is the maximum of, as we discussed, we need 3 things. So here, I repeat that 3 times. Else pass. So if the first 2 characters, so we can add 1 by I and j, so removing, we are ignoring the very last character from both of the word 1 and word 2 because we know that they are equal at this index, and simply add 1 by the top left cell. Otherwise, we can ignore them and then just find the maximum of table I and j plus 1 and table I plus 1 and j. So the maximum of these 3 values would be the answer or for the current cell. Otherwise, if they are not equal, so we can simply just find the maximum. We know that they are not equal, this word, so just assign it to the maximum of those top left and top left cells, and then assign it to table I plus 1 and j plus 1. So at the end, the very last, the bottom right corner of this table is the length of the LC that we discussed in the beginning of this video as the length of the longest common subsequent for these two. So I define LC equal to table 1, the last row and then last column, and we can return L1 plus L2 as we so it was L1 minus LC plus L2 minus LC. So I can rewrite it as L1 plus L2 minus 2 times LC as the answer for this problem. So let's run it. Let's also try the second example. Okay, so let me submit that. Perfect. So that was everything for this video. So we solved it using dynamic programming. So don't forget to always check the solutions suggested by other users. So as you can see, most of them users were suggesting the dynamic programming. So since the length of these two words are at maximum 500, this is a good solution to practice and to apply a dynamic programming here. Okay, so that was everything for this video. Hope you enjoyed it.